So scalar and vector quantities you have done in your 12th class, right? What are scalar
Yes, ma'am.
quantities?
Yes, ma'am.
What are
Yes,
scalar
ma'am.
quantities?
only
The
magnitude but
quantities,
not.
yeah,
मैग्नीट्यूड होता है पर डायरेक्शन नहीं होता है.
सिर्फ मैग्नीट्यूड होता है. There is no direction which is specified. Any example?
Length.
Yeah, length.
Distance.
Why length? Why length is a listen to me.
Speed.
Why length is a scalar quantity and not a vector quantity?
Distance.
Yeah,
जैसे only
distance.
have
हम इसको डायरेक्टली ऐड किया जा सकता है.
Yeah, so there is no need to specify the direction when we are talking about length. So the examples are length, temperature, volume, time, mass. We don't say that time is going in this direction or that direction, or we just specify the mass of an object. We don't specify the mass along x-axis or y-axis. So these are some of the examples of scalar quantities. What are vector quantities?
Ma'am, direction.
Direction भी होता है. Placement.
Yeah, it has magnitude as well as direction. So if we don't specify the direction of a vector quantity, it does not have any meaning. Examples are displacement, right? Velocity. Why velocity is not a scalar quantity?
It has direction, ma'am. And
How you can say that it has direction?
Because ma'am,
It's all a vector of.
Ma'am, because we cannot
Number
directly
velocities, total
add
displacement
velocities.
upon
We
time
use
taken.
vector law of addition
Displacement.
to add velocities.
Because when we are specifying velocity of a person or object, if it is going in plus x direction, if we are saying it has positive velocity, the same velocity, if we have to specify in the negative x-axis, that same quantity will have a negative sign. So it has a direction associated with it. Speed plus direction is equal to velocity. Magnitude of velocity is the speed, and the velocity when speed when it is associated with some direction, it becomes the velocity of object. So displacement and distance, what are the difference between these two?
and displacement is shortest distance.
Ma'am, displacement
Yeah.
means shortest distance covered by body.
Yes, yes. So again, as it is a vector quantity, it has direction associated with it. Displacement, when we are talking about displacement, if we say the displacement between point A and B is this much, we are talking about the direction. Whereas in case of distance, direction is not specified. It can be in any direction. It can be in multi-directional also. So you must have seen this example where the start and end point, as you can see here, this is the start point, this is the end point. The shortest distance is the displacement. Also, it is having a direction. It starts from the start point and ends at the end point. Whereas in case of distance, you can take any route. This, all of these are distances. Also, it does not have one direction. It is multi-directional. The direction changes from point to point on the path. Similarly, acceleration is a vector quantity, and force is equal to mass into acceleration. Again, it is a vector quantity. Some example of forces. Can you provide how force, like when it comes into picture, how it is associated with some direction?
Frictional force.
Yeah, frictional force.
When we move the object, then we have to give it a direction, like right or wrong, right or left.
So we okay. I'll give you an example. Electrostatic force of attraction, right? Have you heard? Coulomb force of attraction.
yes, ma'am.
So this force applies to which type of species?
No,
इसमें
noise
होती
is
है ये
not
force
much.
electrostatic.
And any body having a charge.
Charge bodies.
Charge plus at rest. The charges should not be in motion, right?
Yes.
Electrostatic
Yes.
force is between the charges at rest. Okay, so what is the direction of electrostatic force if we consider two positive charges?
Triple
Suppose this is first
Negative
charge,
charge.
this is second charge. That is, this is Q1, this is Q2. ठीक है, दोनों पॉजिटिव है, ये भी पॉजिटिव चार्ज है, ये भी पॉजिटिव चार्ज है. अगर मैं पूछूं कि Q1 पे किस डायरेक्शन में फोर्स लगा रहा है Q2, तो किस डायरेक्शन में लगा रहा है बताओगे? ये x एक्सिस है, ये x डायरेक्शन. One by one. Don't wait.
Minus x.
Yeah, minus x. So force on Q1 due to charge Q2 is in minus x direction. Clear? Similarly, tell me the force applied on charge Q2 due to charge Q1. Which direction?
Plus x.
Plus x. So unless and until we specify the direction, we cannot specify the force. That is why force is a vector quantity. Then topic is addition of vectors. Okay, so first I'll talk about addition of scalars. Suppose you are measuring the length of an object, right? So on a scale, centimeter scale, suppose the length is in centimeter. So if you want to add the length of two objects, what you will do?
You simply measure from scale.
Yeah, so if you want to add, what you will do? Algebraic sum, right? So in case of scalars, how you add the quantities? You simply do the algebraic sum of those two, or time, or mass, or temperature. But in case of vectors, you can't do that. Why?
Yes, ma'am.
Why you can't do simple addition in case of vectors? Suppose one force is in this direction, yes. Suppose F1, which is a vector quantity, it is in positive x direction. And another quantity, which is F2, it is in negative direction, x direction. If you simply add these two quantities or do the algebraic sum of these two, but you will get F1 plus F2. But you can look at this practically. If you are moving along this x direction in your car along plus x direction, or if you are moving along negative x direction, you can't simply add these two. What you can do, what you will do here, you will subtract these two, right?
Yes,
The
ma'am.
net effect
ma'am.
of these two quantities is the subtraction of these two. So to accommodate this thing, we have to specify the direction. So vectors simply cannot be added. So there are some rules with which we can do addition of vectors. Are you aware of those rules?
Yes.
Yes, ma'am.
Tell me one of them.
Triangle or parallelogram law?
Yeah, first one is triangle law and second one is parallelogram law. So this is the triangle law. First we'll discuss triangle law. What does triangle law of addition